Hi friends, welcome back to another session on operating systems. Have you ever wondered what exactly happens when you press the power button on your computer? What follows is a fascinating process called booting, the act of waking up your machine and preparing it for the use. The moment you turn on your computer, power flows onto the motherboard and the CPU immediately looks for instructions. It is like a student waking up and asking, what do I do next? These first instructions come from the system firmware, either BIOS or UEFI, which is stored on a chip on your motherboard. Think of BIOS, that's a basic input-output system, as the machine's built-in supervisor. It starts running a power-on self-test or POST post to check your hardware like RAM, keyboard and disk, whether it is working properly or not. If anything is wrong, the system beeps or shows an error. Once the post is successful, the firmware looks for a bootable device such as your hard drive or SSD or even USB stick and hands control over to a small program called bootloader. The bootloader plays a critical role. It's like a librarian who knows where the real book is kept. In this case, the book is the operating system's kernel. The bootloader loads the kernel, the core part of your operating system, onto the RAM. Once the kernel is in memory, it takes over and starts talking to all your hardware. It sets up the memory, loads device drivers and mounts the file system like a stage manager preparing everything before a show starts. Finally, the kernel launches the init system, which starts all the essential background services and eventually brings up the login screen. So that's what a booting is. So let's look at what exactly the boot process is. So it's a process of starting up a computer, beginning from the power on to loading the operating system into the memory. This process continues. Basically, there are two types of boot processes. One, cold boot, which starts from the powered off state when there is no power supply. When we press the power button, a cold boot process starts, or there is a warm boot where we are restarting the already running system, like pressing Ctrl Alt L and using to reboot. So the basic steps involved in the booting process. So power on, electricity flows through the system. CPU gets the power but does not know what to do yet. Then starts the power on self-test. It's a firmware that checks if the hardware is working or not. The hardware like the RAM, keyboard, disk. If any of them is not working, then we can't proceed further. We need RAM to load the operating system. We need the keyboard for interaction. We need the disk from where the operating system has to be loaded. If these are not connected, then we cannot continue. Therefore, it just sends a error message, beeps, and then If everything is okay, then it continues to the next one where the BIOS is executed. BIOS is a firmware program stored on the motherboard. It is stored in something like a permanently written memory like EEPROM or EEPROM or EEEPROM, depending on the type of the system we are working on. Then it looks for the boot device where the operating system is actually located. It may be the hard drive, or it may be SSD, or it may be USB. And once that is identified, then it loads a small code called the bootloader. This bootloader is a small program whose job is to load the operating system's kernel. It finds out where the operating system's kernel is situated in the secondary memory, and from there it reads byte by byte and loads it onto a predefined location in the RAM. Then the bootloader loads the operating system kernel onto the memory, and once the kernel is loaded, then the kernel takes over the control of the system. So after a bootloader loads the kernel, the control is given to the kernel by appropriately changing the address of the next instruction to be executed is shifted to the first location of the kernel where it is loaded in the RAM. Once that is done, then the kernel starts the init system, that's initialize the whole system, and then it launches all the necessary services and the user interfaces like GUI, shell, and all that. So that's a booting process. So booting process, where bootloader loads the kernel. So when we power on, the BIOS comes onto the picture, and that initializes the post, and then the kernel is looked in the disk and is loaded onto the RAM. And once the kernel is loaded onto the RAM, then the work of the bootloader is done, so the control is transferred to the kernel situated on the RAM. So these are the various activities. BIOS is a basic input-output system that executes the MBR. MBR is the master boot record that executes grub. Grub is a grand unified bootloader which executes the kernel. Kernel in turn executes the init code, and init code executes the run level programs, and finally the run level programs are executed from the various directories shown here. So that's it for now. In the module 1 we have many things. In the forthcoming sessions, the other modules to follow. So thank you very much for following me. Have any doubts, please reach me on the given mail ID, and all the videos are available on my YouTube channel. So please do like, share, and subscribe the channel, and hope you are enjoying the journey of understanding operating system, and wherein we are looking one concept at a time. So that's it for now. Thanks for following me. Thank you very much.